Okay, Haran, thanks for checking. Let me quickly, for recording's sake, so that it will be useful for all of you. So as I'm mentioning, it's a high demand course and high value course. It's not complicated and it is very interesting. Also, I mentioned there is a huge data is involved, people connecting to the cell phones, people connecting to the cars, and a lot of other data elements. Organizations want to reach customers with products by understanding their buying behavior, by creating a great experience. That way they can win the customers. It's all competition for the customers. It's all competition for the sales. There is no what you call mercy in the competition. So companies are trying to compete each other. When the Google was very small, it's a small search engine in the Yahoo. I don't know if you know or not. Yahoo was using Google search engine in the back end. Yahoo wants to purchase Google. Google asked $1 billion. Yahoo wants to pay some $800 million. The deal broke. Now Google is almost 15 to 20 times to Yahoo. Things change. So companies compete for the customers. Companies compete to create an experience. So as I mentioned in the last orientation session, this is the one which you will be learning. As the companies want to collect and store and process the data, they want to have control on the information. The more they know about the patterns in the information, it can turn into knowledge with which they can take a lot of strategic actions to compete for the customers, to gain more business advantage. So that falls under this enterprise AI. It has these 4 areas in a broad sense. So definitely big data is a foundation. I just mentioned IoT because a lot of data is nowadays collected through devices. Even when companies collecting data even from a phone, you can think it as IoT because the Internet of Things, the phone is connected and the car is connected. And in enterprise or in industry, different machines can be connected. So, but those hardware, the sensors, all those things, rather we need not concern about it. For you, it's a seamless. You're in software. So you are in a position to collect this data using a softwares like Kafka and some data ingestion platforms. But you don't need to worry much. But what I want to try to say is the big data is a foundation for this. But it is not just big data course. This is not a big data course. So at the end of this whole course, with some additional practice, you can aim to be a large-scale machine learning engineer. That is number 1. If you focus on these 2. If you focus, in addition these 2, I strongly encourage to get this knowledge. Even if you are going here, having this knowledge gives you a lot of edge. So with this knowledge, you can try for an enterprise AI engineer career or large-scale machine learning and artificial intelligence engineer or consultant. In the last class I mentioned, machine learning broadly touches these 4 areas of the problems. You go to industry, a lot of problems fall into, at least 80% of problems as of now fall into these 4 categories. I don't discuss details of this. Their regression, it's an algorithm with which you can predict the future value. Classification, is another class of problems where you divide the problem into yes or no. Something like a mail is a spam mail or no spam email. If you apply for a credit card, you accept or deny. If you apply for a job, they either accept or deny. So it's a classification, means either this side or this side, something like this. These two are very interesting problems, very much used. Clustering. Clustering means grouping of things, grouping of customers, grouping of population, grouping of some data, network data, when people trying to access the network, identifying the patterns, how to group these access patterns. So are there any outliers? Something like this. And last one is product recommendations. Companies based on customer behavior, companies can recommend the services, the product. So this is very much valuable to the companies. You can start with these two, then slowly get into classification, get into regression. That's why I'll be taking you in the coming classes. Okay, so just get the sense of machine learning. Please see, I talked here about the clustering. Clustering means, as I mentioned, the machine learning programs will be grouping the data. I mentioned in the orientation session, you need to imagine the data as a point, either a two-dimensional point, like customer ID and customer age is a two-dimensional point. Customer ID, customer age, how long the customer is your customer, a three-dimensional point. If there are 4 columns in your data, it's a 4-dimensional. If there are 10 columns, it's a 10-dimensional. But definitely here we are talking about the numerical data. We're talking about numerical data, not category of data. Even categories of data can be converted into numerical data. Suppose you are in a college, first year, second year, third year, you can say numerically first, or you can put a numerical 1. Anyway, let's not get into those details. High level, you need to understand the data are points. So just to want to give a sense that when you say a machine is doing a clustering, what it does actually, how it does it just read the data and cluster it in a one go? Not really. It uses algorithms and it uses iterations. I want everybody to get this point. Next to 10 minutes, I'll touch this. I'll show you in some simulation. Look here. So when the data is given to a computer, all data, imagine them as a points. Now our problem is, imagine the problem is the machine wants to cluster this. Machine want to make it as a groups. So we mention it. Hey, machine learning system, can you make my customer into 4 groups? Can you make my customer into 5 groups? You will mention. On what basis you will mention? Don't worry, there is a way to realize that. But right now, let's think, hey, we want to group into four groups or 4 clusters. Okay, let me quickly check who else joined and new people. Surya, Srini, I already talked. Hey, Shrikant, welcome, Shrikant, attending from Chicago or somewhere in the East Coast. Shrikant, do you want to greet our friends? How are you today?
Hey, I'm fine.
Excellent. Welcome. Shravanti, you want to say hi to your friend? Welcome. Shravanti, yeah.
Hi, Srini. Thanks for inviting me.
Okay,
Hello,
wonderful.
everyone.
Okay, welcome. So let me quickly see if I DK Hari, Emma, Kishore Narayana Raj, Rinku, welcome. You want to say hi to our friends?
Hello everyone.
Okay, welcome. Okay, guys, try to understand. Let me give you a sense of this machine learning, where how the programs or systems use algorithms. First, I want to highlight that you will not be writing these algorithms. These algorithms are coded in the libraries. These libraries are written by software companies. Something like Google might write some software libraries encoding these algorithms. Or Amazon might do it. Spark is doing it. Different packages will do it. We use one set of enterprise libraries, which are called Spark machine learning libraries. But they all use the same algorithms, more or less. If they're using different algorithms, they will mention. But these algorithms usually comes from universities. These algorithms are there for last 10 to 20 years, 30 years. But only thing is, now there is a lot of data, now there is a lot of computing power, so these algorithms have become more famous, so that machine learning became a practice where people can apply, people like us can apply to solve the problems. That's why if you go to some companies, you may hear your job is applied machine learning. So even in your resume or in your LinkedIn profile, you can mention you are a large-scale applied machine learning engineer. So applied means you're applying these libraries, these algorithms which are encoded in those libraries. You'll not be writing a lot of code. You'll be writing few code, but you'll be using a process of machine learning to solve the problems. Okay, but getting a sense of what it does really give you insight and even give you good understanding. Okay, as I mentioned, how a machine make them into 4 groups. When you give the data, they're just points. Machine does not know whether these are the group of points, these are group of points, these are group of points, group of points. Machine uses some mathematical logic. So that's why you hear many times when people talk about machine learning, there is a math involved. Is that true? Yes, it is true. But trust me, it is a very simple mathematics. 10th and 11th and 12th class people can understand. In fact, it is a very simple mathematics of 10th and 11th and 12th class, even not full mathematics. Okay, look here. So here you suppose you have a set of points. How machine go and make into 4 clusters? Just imagine. So what it does is, first, it does not know as a groups. Even though in this picture you see them as groups, it does not know them as a groups. You ask the machine to make into 4 clusters. So what it does is it randomly fixes 4 points. Siva, I might be asking a few questions here and there. So please respond to me. DK, Harun, everyone. So Hema. So what it does is it fixes 4 points first, because you asked 4 clusters. 4 points it fixes. If you see a cluster means you have points, but there is a central point. It is called centroid. It's like a group leader. You know, in 10th class, 11th class, or your cousins may be studying centroids. Centroids are nothing but average. If you have x1, if you have a points p1, p2, p3, centroid is p1 plus p2 plus p3 by 3. It is just an average. So if you have a points x1, y1, x2, y2, x3, y3, the centroid is x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. You're just adding those coordinates and dividing with this number. Okay, so when you ask the system to make into 4 clusters, it fixes 4 points first. Not here, it might fix here, it might fix here, it might fix it. So very randomly it fixes. So I'll assume this is the point. Somewhere this is the point. Somewhere this is the point, this is the point. 4 points. Siva, are you getting this? Siva, am I clear? Yeah. You're on mute, Siva. Okay. So this point, Harun, can you hear me?
Yes, Srini.
Okay. So
the 4 points also can be at in one cluster also, right? Initially it doesn't know.
You're right, DK. That's correct. See, assume this is here, this is here, this is here. Randomly, anywhere they can be. You're right, DK. Okay. So then what happens, you see? So what happens is, you imagine the distance of, so rather let me put it in this way. All these points will be, or take one point. This is the centroid, one out of those 4 points. Now I'm talking about other points, non-centroid points. Or even the 4 points, DK, as you mentioned, they can be in this cluster. Even they need not be these points, right, DK? Because it's a random coordinate, right? You are choosing?
Yeah.
Okay. Suppose this is the point, okay? That is not even the really the real centroid. But generally it takes one of the points because from the data itself it takes. So let's take here. DK, you're right. This is the point. Assume now this is number 2, this is number 3, this is number 4. Again, you know, these 4 falling here, it is also may not be possible, right, DK, because it's a random, right? DK, since we said random,
yeah.
Again, if we say 1, 2, 3 means again, we are choosing a 4 points almost coming to near to a set of points, right? That is also not possible, right? So randomly means it may be here, it may be here, it may be here, somewhere here, right? So let me put, okay, 1, 2, 3, let's take 4, okay. Then what happens is, now these are the centers first. So all these points should belongs to one of the point. What does it mean? What it uses is, it uses the distance. So every point in this, what you see, will be near to one point. Those 4 points, say the 4 points we have chosen, every point in this data set will be near to one of the point, or it may be equal also possible. Is that true, DK, Harun?
Yeah.
Every point, say you have 4 points, or you even take in our own people who are attending now in our class. Say DK is 1 point, assume Harun is 1 point, Surya is 1 point. So every one of you, Hema, you should belongs to one of the point. Do you belongs to Hema, Harun, or DK in Hyderabad? The nearest point, distance. Hema?
Yes, Srini.
Nearest
is Harun.
Exactly. So you belong to Harun. So Kiran also, because the distance, yeah, US Harun. But somebody, Lakshmi and Surya, they're in Hyderabad, they belong to DK. So like that, all these points belongs to one of these 4. There could be a couple of points, maybe equal also, but that's okay. They can be either this point or that point. It doesn't matter. In the iteration, further it will narrow. Then what happens, you see? Now, DK, the question to you. Say, suppose now this is the point. Assume a few points are belongs to that point. Or even you take this one. Assume these are all the points, but this is the DK. Okay, this is DK, and all are these are your friends. Distances. Now you guys want to host a party. Now you say this is the DK house. DK, what your friends will tell you? Hey, DK, your house is a little bit far from many people. Let's choose something common, you will say, right? DK, is that right?
Yeah.
So then it means this. Now when you fix the DK house, first you got the friend circle. Now, after seeing the friend circle, don't you think the centroid is moving? Centroid becomes somewhere, comes here. Now this is the friend circle. Earlier we say, hey, you should form 4 groups. This is the DK. Now somehow nearest distance, some people form. Now after they form, they're deciding where to host the party. Now DK house is here. So, okay, it's all good. We all belongs to one group. But for this group, maybe this Razu house or, Surya house is maybe better, because which is the equidistant to all the points. Again, this is the centroid. What is the centroid? It is nothing but mean of the average of all the distances. Okay. Okay. Here also it is the same. Hema, this is the Harun's house. Hema and all other friends formed, but it's all Harun's group. But after forming the group, Harun is not near equidistant to all. So then they decided to change it to Hema's house. Now this is the Hema's house. Now Hema house is fixed. Or this is DK house. So this is the DK, and now other person, Lakshmi's house. Let's say Lakshmi's house is fixed. Now again, since the centroid changed, now the centroid changed. DK, is that correct? Since the centroids are, the 4-point changed now. Again, don't you think the group again changes? What I mean is,
Srini, how do you come up with those 4 points? Is it just up to us, or is there any
random.
reason?
Don't worry. It's a 4 clusters we want. We want 5 clusters, 6 clusters.
Oh, so it's just it's up to us.
Yeah, first we are starting. Yeah, that is correct. That is called hyperparameters.
Okay.
But there are some strategies. Yeah, how many optimum groups should be there, etc. That we'll figure it out. But first, let's see what it does actually. Okay. Let me show one simple animation. Now slowly, let me finish one more line. Now you see. So what happens is, once you fix the randomly points, 4 groups, first groups will be started. Once you fix the group, centroid will be moving. Then you fix the centroid, then the groups will be forming. Then fix the group, centroid will be moving. Then fix the centroid, group will be changing. Please understand, it goes in iteratively. So again, I will start. Random points, 4 points, 4 groups will be formed. Once groups are formed, the centroids will be changing. The example is this. This is the DK house, a group formed. Now the centroid moved because they all decided house should be equidistant to these points. But since now the point is here, maybe this somebody, now okay, party is here. Maybe now I am near to you. So this guy may fall into this group. Earlier, this guy is, when this is centroid, this guy belongs to this group. This guy does not belong to this group. Now the centroid is here. Maybe this distance is nearer because the centroid moved this side. This distance may be less. So in a high level, this randomly fix the points, fix the centroid because you want 4 groups or 5 groups. Based on the centroids, groups will be formed. Now you have group, so centroids will be moving because you are averaging it. Now again, centroid is fixed, so groups will be forming. Now groups are fixed, centroid will be moving. Now again, centroid is fixed, new groups will be forming. Like that, it iterates until in the cluster there are no more big changes. As that happening, you see, even in a physical world, if you do it iteratively, after some time, okay, I think we are good. Couple of points here and there is not a big deal. In analytics, couple of points falling into that group, this group is not a big deal. But overall, 4 groups are formed or not. So let me show you one more diagram, then we'll open it for discussion. It's a very interesting, a simple algorithm. Let me. One second. Can everyone see this? Let me go. Sairam, can you see this picture?
Yes,
Yes.
Srini. Yeah.
You see? Do you see the step 0? Because I want to make sure I'm sharing right. Is the step 0 right? Shiva?
Yeah.
Okay. Let's see here. See, without talking, I'll just with the basic understanding whatever we have, I'm going to do slides of this. Let me go back again. One more. Okay. Just now, can you please imagine this without really worrying it as a complicated? DK, any comments on this or any questions? I mean, just a thought of that.
Yeah.
Clustering
Right.
algorithm.
Yeah.
You get the sense, right?
Mm-hmm.
Can you articulate in a couple of lines?
Yeah, I mean, whatever you said, right? I mean, initially, in this case, it is 3 clusters.
Right.
So we randomly choose
Right.
3 centroids,
Right.
and then basically compute the distance, and then we'll move the clusters, and then
Excellent. Right.
right.
That's
So,
correct.
yeah.
Yeah. Harun.
Srini,
Yeah.
yeah. So I think it's only the centroids that are moving, not the actual points. I think that is something that we need to understand.
You are right. The centroids are moving, but the points that belongs to a cluster will be readjusted.
Yeah, so only it says that now this point, the leader, this point belongs to has changed. Previously it belongs to this leader, now it belongs to this leader. That's
You are
it.
right. You are right. Those points never change. Only centroid
Yeah.
is change, right? Hema's house is the same, and Harun's house is the same. Harun was the centroid where everything is decided party. Now after that, the party house is changed. So it went to Hema's. But who belongs to that group? Now maybe a new person who is in DC, who may be earlier close to someone, to Hema's. They may now belongs to, who is close to Kiran's, New Jersey. Now they may come to close to Virginia, to Hema's house. Yeah, any comments, Shiva?
No, Srini. I think as DK said, the moving part is centroid. I think when they have that optimum distance, those parameters, I think they just stop moving with the data.
Correct. So, yeah. So don't worry about this algorithm. They're a little more close, but I just want to show you the iterative aspect of it. Let me go again. Some improved algorithms are there, but don't worry about what it is. Just see, I want to give a high level sense that the computation is not just a one shot of computation. The program literally goes to, as DK said, fixes the points, has to compute the distances. That way they form the group. Then because they form the group, they can calculate again the centroids, averages, so that the center is moved. Arun is right. The center point is moving. In fact, center point is moving. It's not the point that is moving. The centroid, instead of earlier fixed point, it came to a new point. So a new point became the centroid. Once the new point became the centroid, so again the new groups will be formed because some other points may be nearer to that centroid. Right? Like that, it continues the iteration. Sometimes 5 iterations, 6 iterations, 10 iterations, until there are no more changes. No more changes in sense, all are closely close proximity. They use certain scores. Okay, now not big changes are happening. Maybe here and there 1 or 2 points are moving here, but it's okay. It's a fairly good clusters like that. So that iterations are done. So these iterations are nothing but a computation on these points. Please understand. So when you have so much data, even 1 gig, 10 gig, 100 gig data, when you are doing that fixing, finding the distances, again this one, all this is a computation intensive, and moreover, it is not a one-time computation. It's an iterative way. So sometimes there could be 22 to 25 iterations. So there's a lot of computation is involved. These computations are done on the clusters. So a lot of memory, a lot of IO operations are involved. That's why for machine learning, the traditional MapReduce, etc., were not successful. There used to be a programming model called MapReduce. So they fail in the machine learning. Instead of 1 hour computation of a model, it may run 10 hours of computation of a model. But let's not get into so much theory, but again, get the sense out of this. Again, my one-line understanding I want to encourage you is, oh, these computations does in iterations, doesn't do one shot of just computation. They do iterations. I think you might have studied numerical analysis in your engineering or in your undergrad. There also, when they're doing a simplex algorithms or few optimization algorithms, they call it as a iterative approaches, they call it. Anyway, so here you see here another. So anyway, don't worry about it. This is not fully Kmeans, a little bit a different algorithm. Let's not get into it. So what I want to highlight is that point only. As I mentioned, these Kmeans is the one which is the very commonly used for the cluster. So then what does it mean? Oh, okay. So this involves a lot of computation. So we need to know how to handle the data, how to access the data, number one. Number two, how to write the programs to do this computation. Number two. Number three, we need to know how to use these libraries which has these algorithms coded so that we can identify certain models of the machine learning. So I'll take you slowly another step. So how you do a little bit programming, how these libraries comes into the picture. So then why we need Scala functions, why you need Scala classes, Scala objects, why you need collections, different things. Slowly you get the sense of it. Oh, then it makes you sense. Oh, okay, this is why I am doing. This is why I'm doing. The more you know why you are doing it, you'll get a drive, you get an interest, and you will start looking into books, looking into friends, collaborate with them, and learn a lot of this. So, any question, guys?
Srini, Kishore, here, one question. Okay.
Sure. Yeah.
Yeah. So, Srini, to fix a centroid, okay, what are the prime attributes? Is it only the computation of distance or the weightage of points is also considered?
No, here there is no weightage here. See, it's a purely, nothing is, their relations are not known to you. Nothing is passing into anything.
Okay.
That is a neural network. In neural networks, you have clearly mentioned, hey, some input should be given and you should get output. There it is an input-output concept. Here it's a purely some data. I don't know what are the relations between them. What are the relations between them? But
okay.
I want to know, can you group into 5 groups? You figure it out based on the number of columns, either weights, not weights, sorry, age, how many years this customer is with the company, and how many products they have purchased, and how much amount they have spent based on worth of the customer, a lifetime value of the customer, a geographical distance, some other patterns. You will not tell to the system a group it like that. You'll just say, hey, I want 5 groups. You figure it out. So that does the optimum grouping of it. Optimum grouping of means optimum of all the things.
Okay, so the only input technically.
Comment?
Yeah, Arun.
Yeah. So see, the clustering, I don't know if that's a good example, but I can give you something like, say, if all these points are like bank customers, right? Addresses of the bank customers, and the bank decides to have some ATM locations. So the number of clusters may depend like how many ATMs does the bank want. So if you have 5 ATMs, now the location where that ATM should be is like centroid. So that will be different. Now, if your bank wants 10 ATMs, then it will see how many customers should be close to that particular ATM. So that might define number of clusters and the centroids where the ATM centers would come. Something like geo-clustering.
That is a good example, Harun. But Kishore, to tell you, it is a bigger thing, bigger dimension. Harun gave a very good example of 1 dimension distance. But when you have many dimensions, 10 columns, the distance is not real distance. Please try to understand. The distance is not physical distance. Harun has given ATM physical distance. That's a good example. But here, these are distance between the points, not distance between the geographical distance. Harun gave an example, very good example, that is geographical distance. But you need to see here in the machine learning, you need to see the data as a points or vectors. Okay? When they are vectors, they are points in that dimension, 10 dimensions points, or 2-dimensional point, or 20-dimensional points. So they are nothing but the points. So, okay, now you want to find the patterns, groups. Okay, grouping concept, yes, okay. They use mathematical logic of the distance and centroid. There are a few other clustering algorithms also. Let me not get into that for now. As I focus on it fully, I'll give you those points, but we will be deviated. First, did you get that sense?
Yeah, Srini. So Srini, my only understanding right now is technically we should give, the only input to the machine learning algorithms is, so give the number of clusters you want to divide it, and it has the intelligence to like group it across for us.
That's
so
right.
Is that we can like take it at this point of time?
Absolutely that only.
Yeah.
Absolutely that. But I told you this iteration aspect just to give a sense, because some people just, it's in one line, you can group it actually. They think that it just computed something, I don't want it as a block back. It does a lot of iterations. That is what I'm trying to say. Okay.
Okay.
Okay, now let us get into it. Hey, how to write these programs, how to compute it, how to use those libraries. Why these Scala functions are needed, all those things. Okay, let's move forward, guys. I know you might have a few more questions, but it helps to move forward. Okay. Now, everyone, I sent you the instructions. Maybe after some time, after you go home, everyone, please create one account here into Databricks. So we will start the programming with this platform where it will be easy to start. Then I will show you another environment where you can do. So first let's start here. See here is a try Databricks. Go here, you don't have to do it now. So get started, it's a community edition. They give you free for students and education institutions just getting started with Spark. They give some cluster with 6 GB. So this is where you start. So what happens is after you do it, you can log into this. So you go to a cloud. I hope everyone can see this. Kishornan, can you see this screen? Okay. So let me start with you in a very simple programming sense. Some of you, okay, before I get into programming, just I want to cover a couple of slides. So in any machine learning, general process is this. You get the data, do some cleanup or prepare the data. Sometimes, you need to prepare the data as a vectors, okay? Some manipulations, you might have to remove one column, whatever it is. So getting the data and doing it needs a programming. The programming we use in this large scale machine learning is Scala, it's a language, and a library called cluster computing library called Apache Spark. Very famous, these two. So we'll be using those Scala and Spark and addressing these two. Get the data and manipulate the data. Then in any machine learning, say you want to make clusters. So that is called, you need to train the model. The train the model is the one actually, which does the iterations and the clusters. So when you train it, then whatever you trained, you get a model. You want to test that model, because what is the guarantee that whatever you trained is reasonably good? Is reasonably good. So you need to test on the test data. So that's why when you have a lot of data, you want to use the whole data to train. You will divide the data into training data and test data. Maybe 80% is for training, 20% is for testing. Okay, on 80% you train the data, train the model on the data. You get the model. Model means in our case, Sairam, in the case of clustering, the model means what are the centroids of the clusters. That's it. Ultimately, what it is doing at the end of the training and end of the clustering, it made 4 clusters. It means it made 4 centroids. Okay. Then once you have the centroids, you know that group also. You know that group. You know that group. So centroid and the group. Centroid and the group. So this is the model creation. Then you apply that model on the test data, the 20% of data, to check. Okay, so this point is belongs to this particular centroid. This point belongs to this centroid. They looks good. That they are falling into right clusters. This model looks good. Then you apply that model in the real world for an application. Of course, there is one more point, improve the model. Sairam, you asked me a question, right? How we decide, hey, it's a 4 or 5, how it knows. Yes. We calculate the efficiency of that particular whole model and the system. So there are various ways to calculate the efficiencies. I'll talk about them later. So that would take you to a decision how many clusters we need to make, optimum clusters. 4 clusters, 5 clusters, 6 clusters. Suppose you made 6 clusters or somebody decided 8 clusters. Between 6 and 8, nothing is, no much improvement of the overall score of the system. Then it's not a big deal. You might decide to go for 6. So hold on some time, but let's focus on this 1 and 2. So it's about data. You need to know where is the data. You need to know what data you're handling. Clean and prepare and manipulate data. You need to know how to compute. You need to know how to program in Scala and Spark to handle the data. So I'm going to focus on this. So some of you who attend my sessions, Spark sessions, it's going to be a good revision for you. Good revision for you. But please feel free to contribute so that new people, new friends feel more comfortable. But at the same time, you will not get bored because you'll see a different screens and different versions also. So please stay with me. Okay. DK, any questions? Okay.
I'm good.
So let me make it a little bit bigger so that you can see. Okay.
Srini, we're not able to see the screen on the left. I think it's...
Oh, here?
Yeah, okay, it's fine now.
This is okay. This is okay. Okay. When you log into this particular Databricks platform, here you can create a notebook. You can call it as any notebook, say test sample or anything. You can say Scala, Python, or SQL, but just choose the Scala. That will take you to a screen where you can write your code, something like this. So let me say it. So Siva, Kiran, you all know in Scala, like any other languages, you can declare variables. Kiran, say you can run this cell. It asks you whether should I launch the cluster. It will take a first some 30 seconds to attach this notebook to a cluster. We'll talk about the details of the clusters after some time, and in the coming classes. But my focus today and tomorrow is to write the program. Okay, so Scala is a very interesting language. You can declare variables with var and val. See, if you declare val, this variable name val, when you declare with val, you cannot overwrite this variable. So in the cluster, the programs will be running on a lot of machines. There is a concept called functional programming. In the functional programming world, the variables will not be overwritten. It uses a lot of multi-threading. There is a concept of thread safety, where the variables should not be overwritten with multiple machines trying to run the multiple threads. That's why they use immutable programming. Immutable means as much possible. It is not that 100% you need to be write immutable variables. Maybe 90-10. 90% of variables you may be making immutable. Means you cannot overwrite. Or 80%. You will choose based on the in the situation. But as such, in general programs you write, most of the time you'll be using the declaration var. Another is var. Var means you can overwrite that particular variable in the program itself. Okay. So please understand the Scala, this is a variable, the type is inferred. It knows the type because you put in the quote. Okay, so in the same screen I'm writing value distance. At what distance she is in from, say, from India, some 3,000 miles. 3,000 miles. Or distance of friend Kiran is there from India. So see here, this variable distance is an integer. So Scala can infer the variables. So if you, other booleans, all those things you can declare. I'm taking a data, you can declare collections. Collections means collections, group of data. You can declare arrays, lists, some maps. There are multiple collections. Tomorrow, Arun is going to introduce to you, rather, not, I'm going to introduce now, but tomorrow, Arun is going to give you more exercise, give more insight. He's very good at that. He's going to help you. So here, I'm just taking a data as 3, 1, 2, 3, 4. So it's an array. A data is an array of integer. I don't need to mention the data type. Please note here, data is DK. Data is an array of integer. Scala infers. In Java, you have to mention it's an integer array, something like that. Okay, that's good. So you even have your data. Yes, let me put as data. It can be a string, array of string of the data. See here, Harun, is a single quote or double quote? Double quote, okay. So look here, I'm taking a string. How I'm taking a string? You see in a file or in a table, you might have a data like this, the employee ID 123, comma. I'm putting a comma because I'm seeing a record as a customer record as a string. 123 is the customer ID, and customer, how long this customer is. Last 4 years he is our customer, and he is in the California, he is in Lakshmi in Hyderabad, and country is India, and that's enough. Some zip code. Okay, this is the first customer record. Second customer record is Harun. So Harun 124, 123, 124 from 5th is there 5 years, is in NC near North Carolina. I don't know, this is not a state. It's in US something. Okay. So the record can be, third record can be, yeah. So 125, comma, where is it? In California, or how long it is? 2 years, or someone in California, in US. If you see here, this is the record in a table, but imagine it as a string. So I have array of string. This is one string, comma, this is another string, this is another string. So let me run this. So here, see here, S data is array of string, array of string. Let me print this, S data, sorry, even you can go to another cell. S data for each println. You'll get used to the syntax. So it means for each of these elements, you are iterating into it. Harun will explain tomorrow more, but just see. See here. Now DK, please see. This is how generally you see in the files, right? 1, 2, 3.
Right.
This one. Now imagine, see here. So imagine a file can be, from programming point of view, can you imagine a file as an array of strings? Suppose you have 1 billion rows. Can you imagine an array of billion elements you can write? Right? See here, this is a file assume. File. The data will be like this, right? Customer 1, customer 2, customer 3. A 100 gig file may have a billion rows in that file, right? So you can imagine those billion rows from the computation perspective as a simple array of strings. Okay, so whether each element is its own data, that point will go later. But if you imagine each row as a string, ideally we should split them. This is employee ID or customer ID, how long it is. That metadata will figure it out. But just imagine a file can be. Surya, are you with me? Are you with me? Can you ask me a question or can you endorse this? A file have a 3 rows here. Of course, I didn't show it as a file. I shown you as a contents of the file. Okay, this is the contents of the file. Even in the file, you see the data like that. So 3 rows are there. You see these 3 rows can be imagined as an array of 3 elements. Surya?
Yeah, Srini. I mean, we have taken the we have inserted the 3 rows to the array, and we have just doing the println.
Correct. Okay. So let's see. So programmatically, even in the data, you access the data from a files. You may ask me, oh, data will be there in tables. Hema, you've been dealing with data in tables, right? But when it comes to analytics, when it comes to big data, all those data in RDBMS tables will be pooled, will be ingested into big data platforms like either Hadoop or S3 or Cassandra or Mongo. They are sent to either NoSQL databases or HDFS or S3. They're stored at some places. So in S3 and HDFS, the data is not stored in tables. The data is stored in files. In databases like MongoDB, they call it a data stores actually. What is that? They store as a collections. Who said that? They store as a collections. You're right. In databases, data sets or data stores or databases like Cassandra, they store as a columnar. A columnar. They are not a relational database. They are designed for scale. They are designed for partitions. They are designed for the cloud. So that is how the data will be. So those data is a OLAP data, online analytical processing data. They are not OLTP data. That's why for analytics, you won't hit the RDBMS databases. They bring all the events, all the changes, either in real time or in batch into these softwares. So that is where your analytics related applications are built, machine learning related, or even reports related. All those things will be built. I'll talk about that later, but just from programming perspective, that would help you. Oh, okay, you will be accessing files. Files, you can imagine general files, general text files, general CSV files. You can imagine them as strings. Each record is a string. Those strings from programmatic perspective, Scala and Spark uses them as an array of strings. Then how it manipulates, how it splits, that you can figure out later. But high level, you see like that. Okay, let's go further. So what you can do, what are the other things you can do in Scala? See, in Scala, you can do operations on the cluster, on the collections. See, like data is a collection. You can do operations. You can do operations, some functions. This data is an array. They have functions, built-in functions. These are a little bit higher order functions. Map, flat map, filter, all those things. We will be helping you to teach, but I'm just giving a sense of it here. The map means, what the map does is, it takes each element of that collection. Here the collection is array. Each element, to say each element, you can say X or I, some any variable. It takes each element of that collection and can do some computation. Okay. Either I into I star I or some other value. Or this I can be passed to a function, a custom function also it can function. So let me run it like this. First, it's simple. What I'm doing is I'm taking every element, okay, array of integer. So look here, now this data map, taking every element of this data, which is 1, 2, 3, 4, and you just squared it. So the result will be appeared here. Automatically, Scala, you don't have to mention, store this value. It always throws the output. So look here, the output is thrown here into a sum result. It uses some random variable. So it's stored into this variable. But what is output? See here, this is square. So 1, 1, 4, 9, 16.
So that's not a greater than or equal to symbol, right? That's just...
Yeah, that's a good question. Hey, Sairam, what is the symbol name?
Rocket.
Yeah, this is a funny name. It's a mapping actually, but in practice in Stack Overflow or people in the community, DK, good question. It is not a greater than. It's a mapping actually. It's like a function. It is taking to this value, something like that. There's a funny name. They call it a rocket. Rocket means rocket should be vertical, but it is a horizontal rocket. Okay, sir, I'm good. You remember very well. Okay, so look here. Now I'm going to do a mapping to a custom function. See, the mapping idea came from a mathematical function in your earlier classes, like 10th or 11th. We studied at 11th, I remember. But nowadays kids are studying at 8th grade itself or 7th grade itself. So function means it takes one value and map it to another value. The input is, they call it as a domain. The output, they call it as a range. But you don't have to worry. So see here, now I'm defining a function. Everyone, you can in Scala, you can define functions. You can function, I can custom square function. Square function. The function always takes inputs. Emma? So I'm giving an input, X as input. For functions, you need to declare the data types. When you're passing to function, even though Scala is a type inference, you need to declare the function. You can say equal to, or even you can use this one and you can write your code inside. But the syntax, don't worry. First, at least 3 to 4 classes, I want you to focus on the concept and slowly try to understand the syntax. But you don't have to remember the syntax. First, you should be in a position to read the code. Then we'll figure out how to write the code. Okay, so you define a function name, it takes inputs, it can take multiple inputs. The output is just X star X. That is my custom square. So I define this function. When I run this, see here, Emma, your function is declared CSQ. The function is declared. That function has inputs X integer. The output is inferred. Output, this is output. Output type. Output type is inferred. But input you have to give. You have to give. Okay. Now see, I will pass DK. Now I will pass this I to this custom function. So we say map it, but take every element. Please observe. It's every element. Pass it to CSQ. Suppose you don't want some elements, yeah, you can filter it. That's a different aspect. But when you straight away mapping it, it takes every element. I'm running here. Again the same. Which one? 1, 2, 3. 1, 2, 3 is your array. 149Q. So either this way, where is it? You can do this mapping. Let me comment this for that. Look here, I commented this code. This is what that ran. You can comment this code. Let me put CSQ custom. A custom square is some funny square. It squares and plus it does some 2, suppose. Emma, what it is doing? It is squaring it and adding 2. You please see here, 1 square plus 3 plus 2. 2 square 4, 4 plus 2, 6. So what is the lesson? Oh, in Scala, you can declare the variables. You can declare the collections. These collections can have a higher order functions like map, some other things also. This map is a function. But interestingly, this map, you can take every element and map it to some computation, or this map is a function. This map takes inputs and can even pass that input to custom function. So it means a custom function can be passed into map. That's why this map is called higher order function. If you can pass a function to a function, whether a function can take another function, it is called higher order function. So data.map is taking into in mapping into custom functions. So why you need this? Yeah.
Can you store this output into another another variable or another value or?
Yeah. dk data. Yes, d data is array of integer now.
Okay.
It is now d data for each println.
But you cannot modify the data itself because you declared it as val.
Correct. Now suppose they say d data, what is that? You cannot overwrite it. Suppose using some for each or those things. But you can create a new variable and pass it to a function that can be stored. So DK, you're right. You cannot directly, this variable cannot be modified directly because it is a val.
If it is var, then you can.
Yes. Suppose I have a d data is equal to, let me put there.
Yes, it will throw a compilation error because you declared it as val. You are not able to.
I need to, if I put again val, in fact, you're overwriting it. No, because I think here it is a different issue. You cannot add it because it is a iterative. Let me see if I can do this. The d data is already defined as a value.
If you try to assign it to d data again, it will throw.
I need to assign it instead of, you're right.
Where
Val d data is equal to, if I assign it totally like again 1, 2, 3. Let's see, it should run. What happened?
no, you cannot define again as val. So if you have a val, then if it is a var, you can reassign. Now you have to remove that val again.
This val,
Yeah.
right?
Yeah. Yeah, now it will work.
Okay. So you have a var here. which is a D data, is array of, hold on, which is the one I think we have many things. Data is 1, 2, 3. CSQ is defined. D data is where is the computation?
But that's being overwritten anyway. So the line number 9 is not doing anything there because you're overwriting that again in the line now 11.
Right. Let me actually use another cell because I'm using many cells. Now,
this is a kind of an IDE, huh? Database.
Oh, that's a good question. This is called notebooks. It's called notebooks, where it came from the Python concept. Python, there is where you can write the IDE in the browser itself. It's called IPython notebooks. From IPython, people came out with a concept called Jupyter notebooks. Now there is another notebooks called Zeppelin. So Databricks uses a combination of these, and you can write. You can write your Python, you can write your Scala. That's it on the browser. On the other front, DK, there are separate IDEs like Eclipse, etc., where you can compile the programs, where you can deploy them on the server. Whereas when you are working on the clusters, these programs can be written in the notebooks. Even these programs can be scheduled. Even these notebooks can be scheduled. That is a DevOps part. We'll definitely go. But answer to your question, you are right. These are instead of IDE, let me put it as a notebooks.
DK notebook is like IDE plus runtime environment plus some additional plugins like visualization. All those things together, Databricks has given you this community edition where they will give you 6 GB space to run your cluster. All those things together, it is given as notebook.
Oh, okay.
That is a good. Thanks for adding, Hema.
Visualize the results in graphs, everything you can do here.
So here I can override this. This is where is equal to 25. If I put it here, it overwrote and given the net as 24. The same thing if I say val.
Give you a syntax error.
Reassignment to val. Okay. Okay, DK, is that clear?
Yeah.
Okay. We'll go to details. So, any other question? Okay. Let's spend 5 minutes, then we'll take a break. Let me take it to one another notebook. I want to give you a filter aspect. Or okay, let me go to the objects.
How do you open different commands that CMD2, CMD3 and all that stuff? I mean, they are just different programs. So
Okay, that's a good.
Which are unrelated.
Here you have easy. You can write the cells here. Add cells below. So I opened this one. This is where Hema is saying, hey, this notebook has a lot of libraries. Interestingly, here, if I put sh, it treats this shell as this particular cell as a unique shell. You see here? Oh, I'm attaching this. Please see this DK. This cell, Hema mentioned one point. I didn't highlight that earlier. This particular notepad not only run the code, it can run the Unix. It can run the SQL, and it can have visualizations. When you run SQL, you have the data. It will show up after the break. You can do basic histograms then and there itself. And interestingly, these notebooks can be shared to others. This can be, I can share it, these notebooks. I publish. If I publish it, I'll get a URL. This URL, if I give it to you now to our friends, at home they can see, or wherever they can able to see that.
Yeah, they can import the same notebook and run on their own cluster.
Correct. So this is to increase the collaboration. DK, say you have done a work, so you want to share it to a BA, business analyst, where even they can run it. They may not know the code, they can run and see the results. Does that help, DK?
Yeah.
Okay, excellent. Okay, anyway.
Just one question.
Yeah, one more. Yeah, please.
Yeah, Srini, this is Harish. So, is it fair to assume that these cells, I mean, the current cell inherits all the objects of the previous cell? Is that a fair statement?
Yeah, that is correct. They will be there in the state.
Okay.
No, you have to run it sequentially. Once the above command is run and the result is acquired, then only you can use it in the next cell.
Okay.
Absolutely. Haima is absolutely correct. If the code is there, does not mean it is there. As she said, you should run sequentially. When this run, okay, that state will be there.
Okay.
Even after you come, yeah.
The S data will be available for the next cell also, the previous vals, variables and vals.
Yes, DK.
More or less like a shared memory.
Yeah, that is correct, DK. See here,
Then why are you writing in another cell then?
It's
just
like
for
another class, like we modularize the code using subclass, right?
Okay, okay.
So,
yeah,
okay.
That's correct. So moreover, this command, see here, as I mentioned, I put percentage shell ls. It's like Unix. This particular, whatever the account I have, the Unix, so that is accessible to this particular code. So anyway, that is not very much, we will not be using much, but just to highlight the point Hema mentioned, these notebooks, a lot of things are packaged in it, so that at one place you can do and collaborate with the business analyst and others, where you can comment the code. And another last point is, certain environment aspects are taken care. You don't have to import a lot of libraries, a lot of dependencies. All those are packaged into it, so that you can jumpstart your code. After that, you can slowly get into your Eclipse heavy-duty programming, where Harun and our team will help you to import certain libraries in the Eclipse, form.xml, all those things. That's a DevOps aspect. Generally, it hampers a lot of people. A lot of people get overwhelmed to do the coding if they are struck up with all the importing libraries, dependencies, etc. Guys, any other question? We'll take a break. Let me see how we are doing. Any other questions?
Can we run the cells like randomly? I mean, random in the sense like, can we run the cell number 3, 7, 9 in one shot?
All cells are only selective ones.
Selective ones, like we see like command 4, command 5.
No, not two cells.
Not command.
Either all, or you can run this cell alone, as long as there are no dependency.
Okay.
That's a good question.
So it's either one cell or all cells.
Exactly. You can run everything. You see here, there is an option. run cell,
Oh, run all below, run all above.
above, all below. But when there is a
Okay.
dependency, without running all the above, if the below cells don't have any dependency, you can run this. So if below cells have a dependency, first make sure you run this and then go. So that's a good question.
Okay.
Anything else? Kiran, Kishore, Lakshmi, Narayana, Ajay?
Oh, sure.
Okay, okay, great. 10:36 here, sorry, 9:36 California time. We will meet at 9:45, which is 9 minutes. Okay, guys? Okay, thank you. Okay, welcome back. Just want to check if you can hear me. Arun or Shiva, Emma, anyone?
Yeah, Srini, can hear you.
Yeah.
Okay. Okay, everyone, let's go a little more step by step. You understood a basic notebook where you can directly write Scala. In fact, you can even write Spark without any dependencies. Directly, you can start writing the programs. Then I will show you a few other environments so that you understand the landscape. Then as we discuss, Arun and I discuss, you can connect the dots more easily. Then we can go more deep into it. Okay, I took a simple array, everyone. These are my friends here. Andy, number is 123, say he's living in LA. Matt, another number, customer ID or employee ID, living in Tucson. These are strings, array of strings. I'm just printing them, everyone. A simple array. So I print it. Please observe, this is an array of string. The data is array of string. I printed them using this for each. If I don't print, they just shown as data is equal to array of string. See, what is Spark and how it relates to Scala? How it relates to Scala arrays, other Scala collections also. See, Spark is a higher level library which is written in Scala, which run on the cluster. Cluster means many machines. The details how it runs we'll discuss in the coming classes. But I want to show you now how you write Spark programs, Spark Scala programs. Till now, what you're seeing is a Scala way of writing programs.
Spark has to associate it with some language like Scala or Java or something, or is it by itself?
Okay, that's a good question. Spark, DK Spark is not a Spark is a libraries platform which is written in Scala. Okay, so originally, fundamentally the whole Spark is Spark libraries. It means it has a lot of functionality. So they are written in Scala, DK.
Mm-hmm.
So
we just use them. We use the Spark libraries in this Scala programs.
That is correct. So you're writing Scala, but you're writing Spark Scala because you're writing using a Spark. Why do you need Spark? Because Scala alone can handle a lot of data in the distributed environment also. Spark is another abstraction which gives you a lot of functionality to do it. So you don't have to go a little bit low level. So Scala gives you high level objects, high level functions, so that you can do things more easily. Does it help, DK?
Uh-huh.
Interestingly, now it's a little bit out of this discussion. You can write even Python programs also, where you can use even though Spark is written in Scala, but they have interfaces for Python, so that if people who are not comfortable with Scala, they want to use Spark, they can write Python programs, can use this Spark. That's why it is called PySpark. But we will talk that when we do the deep learning and other things. Yes, let me mute everyone. In case you want to speak, please unmute. Okay, thanks. Okay, now let me take you into Spark slowly. So See, Spark, everything starts with an object called a Spark context. I'm calling it a SC. It's already defined in this notebook. It is defined also in a shell called Spark shell. I'll show you later after some time. But when you write your own programs in other editors like Eclipse, you need to build your own object. So how to do that will help you. But right now, for simplicity, Kishore, you might have forgot this long back, you heard. Spark context is available in this notebook. They set up this environment already. See here, look at everyone. Whenever say I type this object is available. So this object is called Spark context that belongs to Spark, which belongs to now part of the Apache organization. So it's a part of the Apache organization. Under the project Spark, there is a built-in object called Spark context. So this is available. There are a few other objects also available. I'll talk about them later. Now, how you make this Scala an array? This is Scala array. How you make it a Spark array? See, when you want to make this a Spark array, you will use SC. What is a Spark array? In Spark, you make this array distributed. What is distributed? Making it parallel. Parallelize. Parallelize. It means if you are handling this data in the Scala, you are in fact handling in sequential. Suppose this for each or any other operations you do, you have to use row by row, sequential. But when you parallelize, you can work on the array in parallel. Means an array of million rows can be divided into 10 partitions. Means 10 groups. So in each group, you can separately do the computations, or you can do parallel computations. So parallelize means dividing the array into groups so that you can work on these groups in parallel. So especially this is a very important concept when you use multiple machines. It means like a project is there, you want to get the project work done by 10 different people. So 10 different people can work on it parallelly. That is the idea. So yes data, I'm just putting as a Spark data. I'm using a Spark context. Using Spark context dot, you need to use this parallelize. If I parallelize this data, what happens you see? I'm taking this data, I'm just parallelizing it. Please observe. Please observe the difference between this data. Tyram, can you highlight this to our friends? What happened between this data and S data? Data is an array, Scala array. Whereas S data is
we can process that concurrently.
Yes,
each line can be processed concurrently.
Correct. It is still an array, but it is a parallel array. In Spark DK, they call that parallel array as an RDD. Please observe. Here, data is an array of string, whereas S data is an RDD of string. So
RDD means?
RDD means, see the map, RDD and array, it looks like the same, but the array means array, Scala array. RDD means it's actually resilient distributed data set. R means resilient, means flexible. D means distributed. Another D is data set. So D. So RDD is nothing but an array. RDD nothing but an array, but RDD is a distributed array. Distributed array, which can be computed, where you can do a lot of parallel computation operations. Okay. At this point, I want to give more insight into this. Don't want to have any confusion on this. Please let me make it below. Look here. How I said C means one object, a built-in object. But what are these objects? In Scala, you can build your own objects. Object, our own friends, AI friends, the AI friends. Who are these? Yeah, just, they're friends, object, AI friends. And they can greet when they attend the class. So it means it has some functionality. I'm defining some function, define function. Greet. They can greet. Hello, AI friends. They can greet. So I'm running this. Let me see. See, I have defined an object. So it means I can call this object. I have defined an object. AI friends can greet. Look at DK. Scala simplifies definition of these objects with easy syntax, a little bit easier than Java. So you can directly create objects even without classes. Of course, and I think in Java also, I think we can create objects. They call singleton objects, right?
Yes.
Yeah. So, but okay, see, this is an object. So this object can have a functionality, which is greater. So now you see, okay, what is this RDD? Let me say, I don't want RDD. I want the ADD, AIDD. Let me put an object, AIDD, not RDD, artificial intelligence distributed data set. How they might have, I want to show you. Okay, I'm not defining, I want the value, or let me say, what is that? An array. What is that? Array of 1, 2. Okay, let me say. I just put some array. An object. I need a function. Define start. It is returning just an array. So what I do is now AIDD, let me define this object, unclosed block. So let me define the block. I'm just trying to show to our team, how these packages are developed. They have used their own notation, how we can use our own notation. Since you came from a lot of Java background, you can easily know it. Let's show to our friend. So AIDD, I don't care about this object. So now I have AIDD, a value, some my own data, is equal to AIDD dot Start. Emma, do you think it works? Let's see. Yeah. Look here. So, different object. This is, since I used it as a function, it came as a unit because it's not printing anything. But what I'm saying is, see, these AIDD, this is a part of this object. So these objects can be declared the way you want. So even if I don't have anything, take this. I think I need a class for that, not just object. Sorry for the little bit confusion. Okay, now let me introduce this class. Class is a blueprint where you can directly create an object. Definitely you can create an object, but many times you need to create a reusable objects. So that is where you will be using class. So in Scala, if you want to build a directly object, you can use the word object. But you want to create a multiple objects or reusable objects, you will be using class AIDD. I have a class of AIDD, which is, I use this bracket. In between, you didn't say anything. Okay, that is also good. Let me say, see here. I just defined a class AIDD. Value, so my data is equal to new. So you are creating your own object, my data. You'll be mentioning new AIDD. It might ask you the brackets, but let me run. This it didn't ask anything. Simple. So any new object you create from classes, of course this class is not doing anything, but at least see here now, DK, my data is of the type AIDD. This is what exactly happened here. Yes, data, of course it didn't come from new, it came from an operation, that is okay. But see the output, S data is an RDD upstream. I defined my own object, my data, it is AIDD. See here, RDD. Since it is using arrays, it is again a RDD of string, RDD of integer, etc. So please get this point. So the Spark uses its libraries, but these libraries are created by people in a modularized way to take it to a next level abstraction. So without any confusion, the point is you can create your own objects, you can create your own classes. Objects you can create directly and can use it here and there whenever you need. With the classes, you can create and can reuse them. But many times in our programming, you'll not be creating a lot of classes because these packages itself can be used to do a lot of operations. You'll be doing applied machine learning related. But suppose you are creating your own, not your own, you're working in Apache organization to build this Spark product. Emma, if you like to build this product and enhance this product, yes, you will be writing a lot of classes and enhancing it. So for applied machine learning, you'll be using the Spark objects, sorry, Spark libraries.
Srini, one question.
Yeah.
So which one is widely adopted, Python or Scala, for implementing this machine learning algorithm?
That's a good question. For big data engineering and machine learning, large scale machine learning is the Scala and Spark ML. For deep learning, more usage is on Python and PySpark. But it depends on the company. In company, you already have a Python team. Even for machine learning, they might be using the Python and Spark ML. Okay. Then one more point I want to mention. After learning Scala and Spark, to learn PySpark, you just need 1 week time. They just go, the syntax and the way they apply is very similar. So anyway, I'll be teaching you Python and PySpark when we go to the deep learning. At the time, even if you want to rewrite your machine learning programs in Python, you can do that. Okay, guys, let me move. So you can define classes, you can define the objects in different classes. But now let us focus on how you utilize the Spark libraries. As I mentioned you, general arrays or Scala arrays, if you parallelize, they become a new objects called RDDs. RDDs are very powerful. So three points you need to, let a cell below. I have some earlier code, don't worry. SC is an object. RDDs, 3 words you need to learn. Transformations, actions. So if you are comfortable with the 3 words, in fact, you'll be comfortable to writing to rather Spark programs, Scala and Spark programs. I want everyone to pay attention to this. Your RDD is nothing but it's a distributed array. So let's see from the from the data point of view. I am taking a sample data using Spark context. I'm going to read this time a file, text file. I'm going to read a text file decay. This text file can be from S3, text file from the Hadoop, text file from this cluster, text file can be, it's not text file, sorry. What I mean is when I access some other databases, we may not say text file. But I'm literally talking about a CSV file, .txt file. In fact, it's a text file, not JSON file, not XML file, not some other formats of the file. Basic text file, .txt or .dat, .csv, wherever the data in the form of text. So I'm taking literally one text file. I have some sample file. How to load a file into this particular cluster, I will tell you. But let me take in a sample file already. It is there, the path. Sorry for that, give me 1 second.
I think it's at 12.
It's okay, let me put it here. Val data is equal to sc dot text file.
So text file is a reserved word there?
Yes, it's a method for the Spark context object. So it's a higher level abstraction Spark has given you. As I told you, Spark made it more easy. You can even read, in every language you can read files, right? DK, even in the C++ and Python. They might do line by line. They might do more lines of code. These guys encapsulated that in 1 line. You can read it. Who's that question?
How is the file loaded in that environment?
There are ways people put it. They either do through SFTPs, or they use it some what you called Kafka softwares, or some Scoop, some other tools. They are just tools. They don't need programming. They're, all the administrators will do it.
Right, but no, on this database where we are doing this program.
This I will tell you. First, I want to show you the programming. Then there is a simple way to do it so that you can practice.
Okay.
So that's a good question. Okay, I'm running it. Everyone, please focus. CDK. Now, sData is a variable. Using Spark context with that reserved word or the method of the Spark context, you can read a CSV files or text files. I'm reading it. As I read, it becomes an RDD. Please observe. Resilient distributed data set. It is a data set. Since Spark has read, it became a distributed data set. It's a distributed. Actually, it becomes an array. That's why it is a distributed array. So it is a distributed data set. It is called resilient because you can do some operations. You can filter it. You can filter some rows. It is a little bit flexible. That is the whole idea. Okay. Now, this sData is an RDD. I told you, you need to be familiar with this RDDs. The RDDs has operations. RDD, you can take few rows out of it. You can just see what is the first element in that file. CDK, the first element is a string, some header, incident number, category, description. It is basically San Francisco Police Department data. So what is the incident? What is the category of the crime? What is the description? What is the day of the week? This is the first row. You can take sData, you can take few rows, take 5 rows. CDK and other friends, I took 4 rows from that file. See, they appear as an array. Everyone, please look. This array. This is the first row. Hold on. Where is the data? Up to this location. Location PDID also. Now this is the data. Let me print this so that you can see it. sData dot. This doesn't work. Just if you say, because you are trying to print the whole data. So how many you want to print? Hey, I want to take 4, then print it for each println. See this. Harun? Sairam, what is this? This is the header. This is the first row of the data. This is the second row. This is the third row. So even though I said 4, it got the 4 rows in that file. First row is the header. Is it correct, DK? Emma, you know this, right? And it's a response. Okay. So this RDD, you can do operations like, accessing the data, accessing some elements of the file, etc. So this RDD, this sData is an RDD of type. And once you have an RDD, you can do higher level operations. That is the whole idea. So I want to do a count. sData count. How many rows are there? See here. I have 10,000 rows. So you can do a lot of higher level things. So wherever is needed, you'll be, those operations, you'll be using it. Now let me move. Hey, I want to
know all the operations that are available. Here you are used take, first, count, stuff like that.
Yeah, we have some common 10 to 15 which are very frequently used, and there will be a documentation. I'll share it with you, where the whole API for the RDD, what are all the operations available will be listed too. Okay.
So here S data is an RDD. Is that what you're saying, right?
Yes, data is an RDD.
And
Yes.
that
Yeah, you're breaking, DK. Okay, now let me go to this simple again. I have a, without doing much operations on that file, I have a data. This is not a file. I can parallelize it. Since this is not a file, to get the RDD out of this, I use the word parallelize. But when I access the file, I will not say parallelize. I'll just say text file. So the program itself, it parallelizes, it makes the RDD. So always remember, whenever you get the RDD, it means it is a parallelized array. So RDD means an array, always remember, but it is a distributed array. Now look here, I want to filter it a little bit. This is the data. I have a parallelized data. I'll print this. Yes, data. I can say take or collect. You can collect all for each. Collect means it is collecting everything. Take gives you how many rows you want. You can now have 4 rows. Okay, I'm going to show you what is a transformation. Transformation. As I told you, these 3 words you are comfortable, should be comfortable. Transformation and action. Action you started already. Yes, data is an RDD. Okay? If you say the first, it is an action, right? You are bringing it. So a method on the RDD is an action. I want a first row. I want to get a 4 rows out of it. I want to collect all this. It is an action. So this is an action. Now, what is a transformation? Transformation means, hey, I don't want this row. So doing a filtering, you're doing some sort of filter, etc. When I filter this, don't you think again I get these 3 rows, which is also an RDD?
Yeah.
This is an RDD. Hey, from this RDD, filter this row. So the result will be again a file, right? RDD, right? Result is again RDD. That is what exactly. So let me copy this syntax, filter. So look here. Let me take this. It's an RDD. Let me. Yes, data. Everyone, please, DK and everyone, please see this line. Not S data now. I want a filter data, F data. I'm taking this yes data. I'll use a higher level method called filter. So it's like it acts like a map almost. So I'm taking each line in that RDD. S data is an RDD. In the S data, I'm filtering. I'm taking each line. How I'm filtering? I'm mapping each line to a line contains mat. See, suppose if I remove this not, what happens? F data, let me mute some people. I see some background noise. Okay, Mukesh Raja, please see. I have an RDD. I have a filter operation. What it does, it takes every line in that RDD, every line, and it is mapping to line. This is a variable. Even I can put X. So it means every row, it is mapping to a row containing mat. So what does it mean? It goes and checks, hey, will it contains mat? So then filter it. Oh, this contains, okay, keep it. This mat, it doesn't contain mat, so we don't need this. Kiran, this is a different Kiran. Does it contain mat? No. Look here. I'm running here. Raja, please see. Siva. What F data did, I collected again. From F data, I collected everything and printed it. That shows to me this filtered every row except the mat. But the filtered one is not in the file. Please observe. Filtered one is not in the file. So if you use a filter, a tea, coffee filter, it filters something and you get the output out. So you don't get confused. The filter, line mapping to line contains mat means only give the output that contains mat. Suppose I use a not. Please observe what it does. Sairam, what it is doing? Sairam, can you take the lead and explain these two?
Now if you put like exclamation mark, that means like you pick up all the rows that doesn't have the mat in that. So it excludes the mat and returns all the 3 rows.
Okay. So can you explain everything? What happened here? This is S data, right? This is S data, right?
We have 4 rows of data. In the
this is 4 rows of data.
RDD.
Yeah. What this is doing here? Can you explain?
And the first one is
this one.
We are asking to filter the data in the line that contains the string mat. So wherever in the data, wherever you see the word mat,
only one should come, right?
Yeah, only that one. Because in the next one we are printing it out. So it prints the row of data that contains mat.
Right. Now suppose I use not.
Yeah, that exclamation mark is not. That means exclude mat and return everything else. Yeah, return everything else. So you'll get first, third, fourth rows of data.
So this F data now, is this the F data? Is still an RDD or is it different?
Yeah, that's still an RDD. Yeah, it's still RDD. Yeah.
Still RDD. So is it a transformed RDD? It came from where? It came from S data, right? S data is an RDD.
Yeah.
The S data has a transformation using a filter operation.
Right.
The output is F data. So F data is an output. If I suppose I don't print anything, it will be more visible. F data is still an RDD. Still an RDD. So everyone, this is what everyone, especially whoever already participated, they know. I want Surya to brush up. Srikanth, I want you to understand this. With one line, you get an RDD. Very simple, you see here. One line. If you parallelize an array or you have a file, you will say a c.text file, you get an RDD. You get an RDD. Resilient distributed data set. It is nothing but an array, but it's a parallel array. Those RDDs can have actions. Actions means you can do something on it. You want to first row, you want to collect all the elements, all these things. So those are actions. Third is transformations. RDD has actions. Transformations. See, when you do an action, you get an output. See here, when I do an action, first is an action, you get a string output. But when you do a transformation, because these transformation and actions looks like the same. See, filter also looks like an action. Filter also looks like an action. But we call it as transformation because the output is still an RDD. Shika. But whereas when I take the action, which is a first, the output is a string, only one row. Or I want a count. I want to do a count. How many are there in a file? Even in the beginning, I told you, this is the count. Count is an action because the output is just a number. If the output is an RDD, which is a different RDD, which came from the previous RDD, it is a transformation. Hema, can you summarize this in your words?
Yeah, we have an array of 5 entries. To make it work with distributed environment, we made it as an RDD, which is a distributed data structure of array. To get an RDD out of array, we parallelized it.
Correct.
Then we added some transformation on top of it.
Mm-hmm.
And the result, on top of the result, we applied an action, which is a collect, which performed everything and displayed all the result.
Correct. So question to you. Hema, when you filter, the output is still an RDD or
Yes, filter is a transformation operation, and we are applying this transformation on top of an RDD, so the result will be obviously an RDD.
Okay, that's a good. One more question. So when you read a file using Spark, do you need to parallelize it or it automatically parallelizes?
Yeah, Spark context automatically performs the parallelization and returns as a resilient distributed.
Correct. Question again. Why I parallelized here? Because this data is not a file, it is a data, Scala array, right?
There is no Spark concept here. We just accept a raw array.
Exactly. I have an array. So since I want to show it into a Spark, I parallelize.
Yeah. This val data is a Scala structure, and to make it fit into Spark distributed environment, we made it parallelize and got a RDD out of it.
Correct. So we'll show you in the coming classes, hey, how you even filter a file, how you can remove this header, and based on the header, how to.
And one more thing, Srini, I think it will be better to explain the and actions.
Yeah.
Transformations are like only the algorithms that we write step by step, which will not trigger unless we call an action on top of it.
What is that? Can you repeat?
Transformation is like meditating what we are going to do. When you call all the transformations trigger, right? It's lazy loading sort of thing.
Correct. I didn't highlight that lazy part for next. I reserved it for next question, but yeah, please go ahead.
Yeah, so in these 5 records, I think you can't see the delay, but if you update on the file, it has more than 10K or 100K records, right? Then if you apply the transformation and run, you can see that it will return it in how many seconds it took? 1.12 seconds it took, right? Per count.
Hema, that's good. We'll hold so that to avoid confusion. First, let's go to concept. You are right. So everyone, hey, RDD, everything in Spark is an RDD, first thing. You get data from DK and everyone. Raja, Shrikant, everyone. You access a file from Hadoop. You access a file from S3. You access a data from Hive. You access a data from Cassandra. You access a data from any source. They beautifully simplified every data as an RDD. RDD. Even though they could be files, they could be tables, they could be anything. But when it comes to Spark, a computation, you have to forget whether it is a table, whether it is a CSV file, whether it is JSON file. For you, it doesn't matter. Once it became an RDD, it is an RDD.
Srini, which version of Spark we are using here?
What is that?
Which version of Spark?
We are using 1.6 and 2.0. But right now, this cluster is on 2 point.
2.10 or 2.11? Like latest versions of Spark, I think they are using data frames instead of RDDs.
Yeah, let me put it that way. First is it is an RDD, actually.
Yeah. Underlying structure is RDD for everything.
Correct. So it is an RDD. Everyone, don't get confused. RDD means it's just data in the form of strings, data in the form of array, data in the form of distributed array. But they made some more abstraction on top of RDDs with schema, a structured data, any file with structure, any file with schema is a structured data. They call it as a data frame. We will talk about this in the coming classes. But data frames were originally introduced in 1.3. Then later they enhanced it 1.6. Now they made it very much enhanced in 2.0. I don't want to confuse a lot of people, especially the new people. So just reserve that word. First, let's focus on 3 words.
Right. For everything, the base is RDD.
Correct. Because even the data frames came from RDD. Originally, Hema, for your information, we bought that point anyway. Actually, they are called schema RDDs. Data frames are, when they first introduced in 1.3, they call it as a schema RDD. So it means schema plus RDD is a schema RDD. Then they use the word concept called data frames. That was part of some other languages. So good. Let's bring our friends, let's bring comfort to our friends. Let's summarize everything. So any data source you access through SC for context, you call it as an RDD. That RDD, you may want to do many things in analytics. That may transform. The RDD may be transformed as a transformed RDD. Okay, you transformed it. Then finally, what do you want to do? Hey, I want to write these results to somewhere, or I want to display some data, or I want to count, or I want to aggregate, I want to reduce, I want to do something, some operation for a result. So those are actions. Those are actions. So RDD, transformation, you do transformation, you get RDD. Actions are you perform some methods to get these results. I want everyone to get this idea before we move further into it. Shrikant, does that give you an idea, at least to start?
Yes, Srini. Yeah, I'm following. Yeah.
Okay, very good. Raja, Rinku?
Yeah, I got it.
Yes, really. I was able to follow it.
I know you might have a lot of questions because as you see, you get more insight. But at least to start, we need to build some vocabulary so that we'll be comfortable.
Srini, I have a small question.
Yeah.
Apart from RDD of string and RDD of arrays, is there any more ways of storing data in RDDs?
No, see, what happens is they simplified it. Even though the underlying elements are integers, doubles, when they bring an RDD, they treat it as a string operation. Then after that string, a string can be split. Then those data elements can be converted to the other elements, other data types. If you pass it to functions, the output can be inferred. A lot of internal things are there. So for simplification, they put it as a string.
String operation.
String operation. String element. String element.
You can have your own class defined and you can obtain RDD of that class type also.
You're right. So you have a string. First you have a string, then you pass it to some other even data types that can become an object. That will go. Next class we will show you. Even the string, you split it and pass it to a class. That's what Hema says.
And also one more thing, Srini.
Yeah.
Like in order to make if the data is considered as a RDD of data, then in the Spark context, it is supposed to be parallelized, right?
If it is generally, see the parallel I shown you as just simple example, but in general everything is parallelized. Once you read from HDFS, once you read from any source data,
okay,
by default it becomes an RDD. That is nothing but a parallelized.
Okay. So RDD data is always parallelized.
Correct.
Okay.
Okay. Now good. You understood the transformations and actions and object. Now I'll apply this to a simple example where we try to count the words in a file. I have a file, words. Let me show you that. Where is that, my file? I need to know the path. Otherwise I can, any other question meanwhile, as I set my Word file? So what I'm going to do is next 15 minutes we spend, we'll do a word count. I have a file. That file contains just words. But when I read that file, it becomes a RDD of strings. Each row is one string. I want to count how many words are there in that file. How I'll split that string. Then I get the words. Each word I count. Maybe I'll put, suppose we have Raja, I'll put number 1. Suppose in our class there is another Raja. For that Raja, I'll put another 1. So Raja 1, Raja 1. So how many Rajas are there means I'll add these 2 Rajas. So Raja 1, Raja 1. Raja 1 plus 1. It means Raja 2. I use that. I'll show you that example. That way you get the idea of this RDD, transformation and what you call action quickly. Raja, any question?
No, Srini. Go ahead.
Okay. Okay, let me, yeah, I have a word. Okay, everyone, bear with me. I'm creating a word example, Scala. The SC object is there. I just want to check. Spark context object is available. Writing a cell below. Sairam, DK. I am creating a Word file, a variable. I'm reading it as sc.text file. It is there in this path. How to upload your own files into this path, I will explain to you after 10 minutes. So it is there here. I'm running it. So what is the output we get? We get an RDD, a Word file, which is an RDD of string. I told you I'm just reading it. If you want to see what are the contents of this file, you will know it is not a structured data. It is a, let me, Word file. Take some 20 rows. I'm printing it so that I want to see.
You don't use collect here. Collect means it will collect everything.
Collect everything. You're right, DK. Generally, they don't advise to do collect because if the file can be a 2 gig or 10 gig, you're trying to bring it to your console. It's a huge IO, right?
Yeah.
So you're taking 20. So please look here. A file, it is actually it is a text file. So let me take even 100. It is just a text file. No. This text file you see here, just like it's a text file. So this text file has some gaps also. So Spark treats it, even the empty row as one string. This empty string. So this is one row. This is another row. This is another row. Then another row. I'll show you. If I have a 3, try to take 3. So this is the first row. This is second row. Then another space, 3 rows. If I put 5, one, 2, 3, 4, 5. So I've shown you this is a free text. Just a free text. So Raja, each is a string. See, it's a Word file is a RDD string.
Okay.
Okay. Now I want to do the count of words. What I'm going to do is I'm going to take each row. I'm going to split it because this is a word, this is a word, this is a word, right? I'm going to split it. So let me go here. So I'm going to take the word. I'll say now the words. I'm going to get the output as a word, my words. But from this RDD, I have a Word file, right? Raja? Word file. I'll take this Word file. Okay. There is a transformation called flat map. What flat map it does is it splits. It can take a line. It can split the line. In the output, it flatten it. It means even though this string is split, this string is split, everything will be in one box. I mean, one bag. It's a bag of words. I'll show you what is the difference between map and flat map, but just observe. But let me split this. Again, DK, Raja, this words is a transformation. Flat map is a transformation, right? Because still it is an RDD. So words dot take 5 for each println. See here, the words, right? Let me show you in another way. Just take words, words dot take some 10.
It took only 4 words.
I'm taking 10 now here. Here earlier I took 5 and printed. Now I took 10. Just I'm not using a print statement. I just say take 10. Now it is showing as an array, you see. Array.
But why is that first one is a word?
Which is word?
The first element.
First one, that's not a word, right? It is empty. I mean, it's a blank thing.
Yeah, it's a blank. What happens is if there is a space, see here, this one, they have space, right? So they split that empty. That also is, they take it as a, empty string. So if there is a space, this is an empty string.
It's not a word count.
Yeah, we'll see how it does. We'll see how it does. It is a string. It's split. But for us, these are more important. So, yeah, DK, I got your question, but just keep it.
Yeah, fine.
The string gets split. But what I want to show you is this difference. What it is look here. Why I didn't do this? Say, yum words. What means I want to use a map word file. That map, I take each line of that file, line dot split. Now yum words take 5. Let me use only 5. Let's observe the difference. Yeah. Hema, DK, please observe. The words earlier it is the same. What is that? Here is the output. Where is the output? This is the output of the words. Now let me. I think the print statements does only. This is the take. Hold on. Let me. I don't know why it didn't print both, but let me use 2 cells so that both I can observe. I just want to show you the difference between map and flat map. This is clear, Raja. It's split. Flat map split the words, just printing. But here, map is also printing, but what it did, you please observe. DK, can you observe difference between this and this?
Yeah.
Raja, DK, any one of you.
It's giving 5 arrays, whereas there it's giving 5 words.
So what it did is, in the map also split this, but it split and hold that string together. This split this line and still hold it together as an array. Flat map, it split and mixed everything. Mix everything. Let me go here. Little bit you need to observe. Little care. I have word file. Word file has a lines. If I use a map, I split it. When I split it, it is a transformation. Still, it is an RDD. But RDD of what? Earlier it is RDD of string, but it is RDD of array of string. What does it mean? These are split, DK. This is split. But still they are holding together, you see, as an array. This is the first line.
Yeah.
Second line, forget about this empty string. So second good line is also split, but still they are holding together. They are split, but holding together. Another line, split, holding together. Whereas flat map, it split and mixed all the words. Let me come again.
Yeah.
Imagine just this. Just let me go here. Everyone please observe, especially who haven't attended my earlier classes. Just observe these steps. Suppose I split this, I can split two ways. One is I'm splitting with comma. I'm not putting here, up to here this one. If I hold the, I split and hold it as an array, and splitting this, maybe up to this. Let me put. So I'm splitting this, Shrikant, but still I'm holding them as a group. Is a map. Map, this, I mean, you're splitting the using map. But if I split using flat map, I'll not have this. Everything is split. So split and mixed. Split and mixed. For some people, I just want to give another example. I think all of you cut the onions. Say you have, your spouse has given you 3 onions to cut. You cut the onions, but each onion you cut and put it separately as a group. Imagine that. Or you cut each onion and mixed all the onions together. Onion, whatever you cut together. So flat map, what it does is it splits, flat map split, it splits and keep all the words in one bag. So bag of words. The split using map is split it still, you hold together. Why each has its own reason. Later you will understand, but first try to understand how you split. But in our case, we just want the word count. We don't want the map way of doing it. We want word count means I just want to split using my flat map. When I do flat map, DK, I'm just splitting the words. Splitting the words. Next, I want word count. Before I do the word count, I cannot count it. I mean, it is count the way they do is first one Raja, Raja 1, another Raja, you have a Raja 1. Then we add it so that you don't search around the whole bag of words. So now I'm going word, let me say word count, let me say. It's not a real full whole word count. Word count 1, let me say. Word count 1. I'm taking the words, DK. And now I have a words is again an RDD. I'm taking the words. I can apply. This time I'm using a map. What map? I am taking each element of that. These words. This word. So what is this? Is this, do we need to use the word always? No, you can use an X. You can use X. So, but I'm using just word. I'm using a, I want to count word and 1. If there is one Raja, I will say Raja and 1. If there is a second Raja, I will again say second Raja and 1. There is one DK, DK and 1. Hema, Hema and 1. If there we have 2 Hemas, Hema 1, Hema 1. Then later I will add. So let me do here. So what I'm doing it here, please observe. See here, again, I'm using a map. DK, please observe, word count 1 is an RDD still, RDD. But this time, the RDD of what? See, the output is, word is mapped to word and 1. That's why it is a string and string and integer. Let me print this, you'll understand. Word count 1 dot take again, or take 5. See here. So word count 1 is just nothing but each word. This empty also 1, D1, project 1, Gutenberg 1. So for each word, DK, it is just adding a letter 1. That's it, counting. That's why, since it is a string and number, it is a string and integer. So your RDD, word count 1 is an RDD again. But what is the type of this RDD? Everyone please observe. You need to understand this. It is a string and 1. So give me 10 minutes, we'll close. So let's observe. Hello? Okay. Now what? Well, I want to really word count. What I'm going to do is, now I take word count 1. Now I know. DK, I have D1, project 1. Suppose there is another project, I'll get another project 1. So I can add based on the keys. Reduce by key. There is a result method, reduce by key. Based on the key, you are reducing it. When you reduce, how you reduce? If there is one Raja 1, Raja is the key. You need to add 1 plus 1. So 1 plus 1. You will be taking AB. AB means the 1 and 1, 2 elements. One is one element, another one is one element, AB. You'll be mixing them, A plus B. Reduce by key. The key is Raja. But what are the elements you are adding? You are adding 1 and 1. Raja, is that correct? 1 and 1. If you have, say, suppose you have, say, Raja 1, say, Raja 1. Next is I have Hema 1. There is another Hema 1. Also another Hema is shown. Hema, please observe how we are adding. Reduce by key. Say in your case, this is Hema is the key. So how it adds is, this is A, this is B. A plus B. 1 plus 1 is 2. Next, 2 plus 1, 3. So this is A, B. If you take these two, this is A, this one is A, this is one is B. But
why it's
yeah, okay.
AB means it's not, A is Hema, B is 1, right? A is Raja, B is
that is interesting
1,
thing.
right?
That's why I'm highlighting. Reduce by key is, it takes the key, one key, assume Hema, okay? The key is the constant in these 3. It takes these 3 actually. Let me go.
Okay.
You asked a very good question. Everyone has that question. See here, this is how, let's take Hema.
So what is reduce by key doing here?
Reduce by key is doing, it takes one key, Hema, okay?
Okay.
It goes and collect this. It got all these 3, okay?
So it is okay. You are getting the word key count by key here, not the total number of words in the file.
No. You're right. Each word, how many times it repeated?
I think it's getting the distinct ones.
Yeah, that is
distinct words.
Correct, distinct words. Sorry, I didn't mention that. It is not the word counts of how many. If it is word counts, even this itself is give us
Just
right.
a count action might be doing the job, right?
Count.
Count would do it. Yeah, that's what I was thinking. Yeah.
You're right. Thanks, DK, for highlighting that. There are 270,000 words. So DK brought up a good point that we are not doing a total number of words. Each distinct word, how many times it came. That is the idea. Okay, good. So now reduce by key. It takes one key, then adds this 1 plus 1, 2, 2 plus 1, 3. When it adds, it doesn't do 1 plus 1 plus 1, 3 at a time. No, DK. The way Scala adds is, first it adds 1 plus 1. So first it adds these two. So 1 plus 1. That's why A is this one, B is this one. Second row, second element, but not the key value. So what did the A plus B means? It becomes 1 plus 1, 2. This will be discarded. This will be no more. Next, this becomes A, this becomes B. So this becomes 3. It goes like that. Okay. This is how the functional programming is run. What they do is they don't do, for each, do from 1 to 10, add this, then overwrite this variable. They won't do that. They hide all these routine logics. In one line, they will do everything. If you see, reduce by key, hey, this is the key. Just add the two values, that 1 plus 1. You take two values, A, B, and just add that. Let me do that. What you did? Did I do the reduce by word count, reduce by key? What is that?
Extra parenthesis.
You need extra parenthesis or it already?
No, yeah. Now it's good.
Really? Yeah, you're right. Anyway, this doesn't need a bracket. Now you see, it's again word count, but this time let us see. Let me display. Word count, take 5. DK, please observe. This here. AH, ha, came 14 times. Reunion came 2 times. Bone came 5 times. Let me print more or less all. Word count dot collect. But let me print in, even if you say collect, it comes as an array. It comes as an array, but I want to show it a little bit a friendly way. That is where for each, guys, give me 5 or 10 more minutes, please. Sorry, we already crossed 5 minutes plus please. Now you please see. DK, do you observe this? Raja, Hema?
Yeah.
But why there are 2 commas in some places?
Yeah, the word itself is taken as a comma. So those are some cleanup exercises. Actually, what happens is the word itself as taken as a run comma. This comma is key value comma. That should be okay. Please adjust that for now. Okay.
Okay, fine.
So the idea is this. Okay, great. So there are only some one words. But now you see here, office is there 27 times. But how we did it, please observe. The idea I'm teaching you, not the word count. Of course, it's a simple, but this is used in some algorithms where when Google does the page ranking, they do that. This search key, how many times it came, how many times people search, how many times on a page is, the page ranking algorithm falls into it. But that is not the thing now we are discussing. I'm trying to make you get a grasp on a RDD, a transformation RDD, and an action. So we got an RDD, which is a word count. Then because we want a word counts, a unique word counts, as Saira mentioned, I did a flat map. I didn't do map because in map, those are together. The flat map, it cuts and make a like our onions. Hey, put in the chicken, everything. No. Keep only 2 onions for chicken, 1 for sambar. Hey, then you need to hold them separately, you know. So the flat map did a bag of words. Then you put word and comma 1 because searching again word going to everything, it's a computation intensive. They first do 2 steps, one step is word comma 1. Then they reduce by key. So what all happened? You got an RDD first, then your flat map is also an RDD. DK, please observe, it's a transformation. But whenever you're taking it is a action, your word comma 1 is also an RDD, but it's an RDD of string and integer. This is what Hema mentioned. An RDD of string, RDD of integers, RDD of string and integer, RDD of some other object, they can be transformed. Then you do a reduce by key. You reduce by key. Suppose I don't print. Then I don't print. Even the word count is also still an RDD of string and integer. So this is also transformation. And ultimately you printed. You printed, which is an action. Or you took and this is an action. This is an action. So now look here. I want to see how beautiful is Scala. Now the whole thing, you can chain it. You can chain it. What does it mean? See, word, this is how I'm going to do. What is that? First is file. File is okay. 1 step I can put. Word file. Please, everyone, give me 5 minutes, please. Word, what is the file? Sorry. Words is the file. Sorry, not words is the file. Word file is the file. Word file. Word file dot what we did. Let us chain everything. Chain means all comments, you can chain it. Word file. What we did, Sairam, first? We took the word file. We did a flat map. Flat map, line, each line, there's no need of space, but line, I split this. Then I flat map. Okay. Then what I did, Sairam, can you help me? I got a word. Sairam, you're on mute.
Yeah.
Now, after I split, I get a word. I mapped it to word comma 1. Right, Sairam?
And
then I use reduce by key. Key.
Word plus 1.
It took 2 elements of it. A plus B. Okay. Then I
print.
I'm collecting. Then I am printing. Right?
Yeah. Don't you need to use the word split somewhere?
Line dot split, right? You're right.
Yeah.
Okay. So flat map, line dot split. First I split, then each took 1, I reduced by key, then collected and printed. You're right. Please observe. Please observe the beauty. DK. Raja.
Yeah.
Please observe. So this particular thing, it has a lot of map reduce word count example. In map reduce, the whole thing is done by this code. Of course, there are this you don't need to count map reduce. They use some classes, of course, we use Notepad and Notebook reduce, but they use some mapper class, reducer. This is a mapper class. There will be a mapper class. There is a reducer class. Those classes will be used. They also use the same techniques, but it's a lengthy code. They also use word and one. They mix it, etc. But anyway, don't worry. So what I'm saying is, this is Spark and Scala reduces the code lot. It does a lot of higher level operations, and it does the chaining operations because since it is a functional, the immutable way of doing. No variables will be overwritten, and you can do excellent operations on this. Okay, any questions, guys? Any questions?
No.
Okay, give me
for this
yeah
training session, not for today, in general, this for this batch. Are we going to use Eclipse at all, or is just only on this one?
No, we'll use. Yeah. Okay. So I sent you the instructions to install, not for tomorrow, but next week. So I gave the instructions where you can, one is...
I couldn't find Eclipse icon there on the VM.
Okay, so you need to install VirtualBox. Did you install VirtualBox?
Yeah, VirtualBox, and I imported Cloudera
very good.
VM.
You
all
started
that stuff. Yeah, I'm there. Yeah, I'm there.
Okay, very good. So give me 2 minutes. I will not show how to install, etc. That I will help you after in this coming week. So this is the Eclipse icon, DK, if you get a chance to see. This is the Eclipse icon.
Okay.
And this is the shell. This is the shell, Unix shell. The Eclipse will be using this IDE also for packages, etc. So Sairam, answer to your question is, this cloud is just to give a head start and run few algorithms and get understanding. Then we will work in a balanced way in both sides. So we'll use the Eclipse. In the coming classes, I will introduce. Then we'll use even the Spark shell. So in a just a common way industry develops, they use these three. If someone does not using the Databricks cloud, they might be using a tool called Zeppelin. So very good, guys. I think I covered a lot of things in the first session because especially people who attended the previous classes, they know these things. Sometimes they listen in two sessions. Sairam, is that correct?
Yes.
But I'm going at optimum pace. We need to go at a good pace. Otherwise, we cannot do this lot of stuff in the machine learning, etc. So try to, but at the same time, I'll make sure they are not bouncers to you. So this is where we need to focus on central points first. What are the basics? What exactly it is doing? How these environments are. Few details, hey, I'll give you certain material where you can dig into it. And always remember, the code will be somewhere available, always. You will not really need a lot of effort to write a code. Many times they come as a templates, here and there you can plug in. But at the same time, you need to acquire the ability, definitely. First, focus on readability, where you can read the code and understand. Then we'll give you the practice. But balancing between the machine learning, balancing between Scala, balancing between this one is very, very important. So that's why this whole thing, this will be the part, 50%. This will be 50% until these two are over. But overall, if you see in the whole sessions in the next 2 months, you need to balance between these two. So it's a very challenging, but I'm pretty sure we can make it. I'm very, very confident. So the pace will be little bit aggressive pace. I just want to catch up this. So you might have to do some practice also in the weekend. So tomorrow we're meeting at 8. So we'll have a 2-hour session. Harun will be leading this. He'll be helping us to understand Scala collections, higher order methods. So these 2 classes will give us a good base for next week, where we will directly attack this problem, outlier detection strategy. How
what
to
time India time tomorrow, Penny?
Same 8 o'clock in the morning wherever we met, but up to 8 to 10, 2-hour session. Okay. Okay.
Srini,
yeah.
Srini, this is Karen. So will you cover natural language processing and neural networks, the image detection thing, or not?
Yes. This is the session. This is the everything. Yes.
But here it doesn't specify image recognition. What does it fall under?
It comes under deep learning. Deep learning is all about neural networks. Is all about this one. So first focus.
Okay. So how much time are you planning to dedicate to those two, the neural network and natural language processing?
These 2 are 7 to 8 weeks, 8 weekends. So not 7 to 8. Sorry. How many sessions, Harun, we plan? I don't have the slide. Give me
13, right? 13.
Give me 1 second. I'll open it.
I thought it's 13 or 12 sessions. Probably 13. Or 10 week. 10 week?
Yeah. 7 to 8 weekends. These 2 parts. Kiran?
So, yes, sorry, I should have referred that again. But can someone just not do the DL NLP part and skip the first?
Oh, can they do this without doing this?
Right.
Not fully, really. What does it mean? You need to be, because they need to do machine learning, right? Maybe, see, the Sunday class you can skip. Suppose you attended Spark classes. So from next week onwards, we'll be focusing on Saturday. We'll be focusing on ML. Sunday we will be discussing these elements. These 2 goes in parallel. So you may skip Spark related classes, but not ML, right? Until if you are already comfortable with ML, that is different issue.
No, I'm not.
ML is very, very important, because this is when you do, we can go it very fast, because already these ML strategies you learn. This is important. The getting collected, training models, testing the data, those concepts remains the same. Only thing is in DL, your algorithms changes. What does it mean? Your algorithms are what you call this neural networks. That is the only thing. But the concept again, inputs, instead of inputs, your data files, your inputs will be images. Images. But images also in the form of files, you'll be reading it. But again, you train the network using the algorithm, TensorFlow and machine learning. Instead of Kmeans algorithm, which you use it for clustering, you will use a neural network algorithm. But approach is the same. So machine learning should be very, very strong. Then this will be a piece of cake to do the DL and ML. If you do this already, you are good as a machine learning engineer. But this is a little bit advanced, where a different categorization of problems you will solve and highly valuable aspects you will be solving. Does it help, Kiran?
It does. And so I saw something about Python in the later sessions that you listed in your agenda. So are you planning on using Python for deep learning and natural language processing?
Yes, because deep learning and natural language processing doesn't have a fully supported Scala libraries. And moreover, industry, deep learning and natural language processing, 90% of people use Python and PySpark. Python, PySpark, TensorFlow, Keras, all those things. So these two will be in Python and PySpark. These two will be on Scala and what do you call it? Spark ML.
Okay, that sounds good. Thanks, Srini.
Oh, okay, wonderful, guys. Any other question? Thank you, DK and others, for staying a little more late. I want to conclude it, but it still goes another 15-20 minutes. Any other things? We're good. So tomorrow. Okay. Tomorrow 8 o'clock. So we'll be focusing on Scala and collections. So Harun is the expert in it. He's going to help us. He's going to educate everyone, including me. So every time I learned from him. So looking forward for the session. See you tomorrow, guys.
Thank you. Bye.
Thank you.
Thanks, everyone.
Thank you, Srini. Thank you. Thank you, Srini.
Thank you.
Thanks, Srini.
Thank you, guys. Thank you, Shrikant.
Thank you.
Savanti, Rinku, Mukesh.
Thanks.
Welcome. We will take care of you. So please collaborate. Raja.
Thanks, Srini.
Everyone. Yeah.
Thank you.
Thank you.
DK, bye.
Bye.
Bye, Kishore.
Bye, Srini. Take care. Have a good.
Bye, Narayana. Bye, everyone.
Bye, Srini. Bye.
So, Srini,
yeah, please.
Quick question.
Yeah.
Or something, how do we kind of get hang of? I know we are seeing what you code, but unless we code, we don't know, right? I mean, how do you do it?
Okay, that's a good question, DK. So generally, what happens is from after 2 classes, you'll watch this. Then we'll share. Now I did this code, right? I'll share those libraries with you. Not library, that node, this notebook URL I will share with you. So you can take that and can run it. And also how to upload that file. I forgot to show you today, but tomorrow we'll show you. So that way, in these 2 classes, whatever you learn, in the weekdays, you can practice. It won't take more than 2-3 hours.
Okay.
Yeah.
Okay. Okay. And also, any links to the all the libraries or all the methods that each of them have a kind of. I mean, I downloaded something from Scala, for Spark, some 50-page PDF from the Databricks.
Right. So usually a lot of things are overwhelming. So that's why I'll release step by step so that, it adds the context. Okay, suppose tomorrow you see the collections, then that is where we'll share you a good Scala book where you can practice basic Scala. Then some sample files, some links to a basic Spark API, which is 60 to 70% of project people regularly use. Then extensive reference library API. Does it help, TK?
Yeah. I mean, it was breaking. I think I didn't understand, but that's okay. I'll catch up with you later. That's fine.
Sure. We'll talk tomorrow.
Okay.
Thank you. Bye.
Hey Srini, this is Mukesh.
Hey Mukesh, please.
Yeah, it was a night session. It was more refreshing.
Oh, wonderful, man. I want you to collaborate. This is going to be, going to add a lot of edge so that you can directly focus on advanced analytics than basic analytics. So advanced big data analytics you can focus, where you can apply machine learning and build a career on it. Okay.
Okay, Srini.
Yeah. Okay. Good. Harun, so we will be looking forward for tomorrow's session from you.